Determine the area of each right triangle. I'm going to look at problem 2 with you. 1/2 times the base times the height. 1 times 5 times 3 is 15. 2 times 4 is 8. And 8 times 4 is 32. So this is 15 over 32. And remember, the units for area are squared. So this is 15 over 32 inches squared. What are some of the differences in triangles 1, 2, and 3? Well, they're definitely different types of triangles. Triangle 1 is a right triangle. Triangle 2 is an acute triangle. And triangle 3 is an obtuse triangle. But they all share the same base measurement, and they're all reaching a height of 4. You can see they all reach 4 on that dotted line. Since they have the same base and the same height, all 3 of these triangles, although they look drastically different, all have the same area. Triangle 1, like I said, was a right triangle. Label the base B. Draw an identical triangle to create a rectangle. What is an expression for the area of triangle 1? Let's sketch in the identical triangle. Then the expression for the area of triangle 1. We have 1/2 the base times the height. An expression does not include the equal sign. And in this case, we have the base is 4, or the base is B, but the height is 4. So we could have 1/2 times B times 4 as an expression, or we can think of half of 4 is 2. So the expression could also say 2 times B. Triangle 2 is an acute triangle. Label the base B. And then it says, show how to decompose triangle 2 into 2 right triangles. So if I drop a height down here, I can split it into 2 right triangles. Label the height, which is also 4, and label the bases x and y. What is an expression for the area of triangle 2? Well, this would be a 1/2, the base is x, and the height is 4. And then for this triangle, we would do 1/2, the base is y, and the height is 4. To figure out the whole triangle, we would combine those two areas together. We could rewrite this though. 1/2 times 4 is 2, and 1/2 times 4 for this one will give us 2y. So we could write our expression as 2x plus 2y. You can see here they've sketched in the x for the base here and a y for the base here. Then they've showed it as 2 separate triangles with that area of 2x plus 2y. You could also factor out the 2, kind of like using the opposite of the distributive property. Because remember, 2 times x is 2x, and 2 times y is 2y. 2 was a factor they both had in common, and so we could rewrite it in this format. You could also say that if we combined x and y together, that would be the whole base B. Triangle 3 is an obtuse triangle. Label the base B. Show how to compose a larger right triangle from triangle 3 and a smaller right triangle. Label the height and label the bases of the right triangles X and Y. What is the expression for the area of triangle 3? For a larger triangle, we could come all the way out here, and that base could be labeled with X. For the smaller one, we could sketch in a smaller right triangle here with a base that is Y. The way that we would find the area of this is we would do half of the base times the height, which is 4, and then we would subtract, because this piece isn't actually part of that orange triangle, 1/2 times the base times the height. So this would be 2x, and half of 4 is 2, so minus 2y. But x minus y gives us the b. So it can still be written as 2 times b. Here you can see that large triangle sketched in. The big triangle with the base of x, the smaller triangle with the base of y, the expression we wrote, the factored version of that expression, and then again x minus y is b, so that expression for the area. Lisa and Una both calculate the area of the obtuse triangle. Who correctly calculates the area of the triangle? Lisa, Una, or neither? Explain. Lisa says that the base is 23. Well, this 5 isn't actually part of the base. That 5 is just used as an extension of the base so we can create that 90-degree angle. And then uses a height of 12, which, yes, the height is 12. But we know Lisa is incorrect. Let's look at Una's work. Una says half of the base, and she uses a base of 18, which is correct. But she says the height is 13. And that is not the height because it has to be perpendicular to the base. It should have a height of 12. So we are going to say neither. The area should be A equals half of 18 times 12. Well, half of 18 is 9. I'm going to move up here. And 9 times 12 is 108 centimeters squared. Mr. Perez builds a fence to enclose a play area for his dog. The enclosed area is in the shape of a triangle with a base of 48 meters and a height of 32 meters. What is the size of the play area for Mr. Perez's dog in square meters? So half the base times the height. Half of 48 is 24. And 24 times 32 will give us the area, which is 768 meters squared. Brian says the play area can be a right triangle, an acute triangle, or an obtuse triangle. Do you agree? Explain. Yes. All 3 types of triangles can use the same base. And height, like we saw in the very first problem. They all had the same base, and they all had a height of 4. They were just different versions of the triangle. Mr. Sharma builds a bench. The bench fits into a corner, and the top of the bench forms a right triangle. The bench is 2.5 feet along one wall and 4.25 feet along the other wall. What is the area of the top of the bench in square feet? You can change these to decimals if you'd prefer. Or you can change them into improper fractions. 4 times 4 is 16, plus 1 more makes 17. 2 times 2 is 4, plus 1 more makes 5. I'm going to use the fraction version. So remember, half the base times the height. For the top, 1 times 17 is 17, and 17 times 5 is 85. For the denominator, 2 times 4 is 8, and 8 times 2 is 16. We can change that into a mixed number if we need to, or you can just leave it as an improper fraction. This would be 85 over 16 feet squared. For my class, that's an acceptable answer, but if your teacher prefers it as a mixed number, 16 times 5 is 80, and then we would have 5 extra out of the 16. So there's another way to write it. Mr. Sharma wants to cover the top of the bench with fabric. Suppose fabric costs $4 per square foot. What is the total cost of the fabric needed to cover the top of the bench entirely? So I'm going to take my area and I'm going to multiply by 4. 85 times 4 is 340, and 16 times 1 is 16. Since this one is asking me about a cost, I'm going to want to convert that into a dollar amount. So I can do 340 divided by 16, which comes out to $21.25. Triangle XYZ has a base of 3.4 inches and an area of 4.76 square inches. Let H represent the height of triangle XYZ in inches. Explain how 4.76 equals 1/2 times 3.4 times H represents the situation. We replaced or substituted A with the area and B with the base amount. We've swapped out those variables with what they are equal to. We've substituted those into the equation. Now we need to calculate what the height is. So using that equation, half of 3.4, you can just divide that by 2, is 1.7. Right now, the H is being multiplied by 1.7. So to undo that, we divide by 1.7 on both sides. That leaves us with H and 4.76 divided by 1.7 is 2.8. So the height is 2.8 inches. Triangle ABC has a base of 10.14 meters and a height of 12.2. Determine the area. If I multiply together 10.14 and 12.2, I get 123.708, and half of that is 61.854. This was measured in meters, so this will be meters squared for the area. Triangle ABD has an area of 40.325 square meters. Let X represent the area of BCD in square meters. Write and solve an equation to determine the area of BCD by using the areas of ABC and ABD. Well, we know that the first part is 40.325, and the second piece of the triangle is X, and the total triangle is 61.854. So to solve this, X is being added to 40.325, so we need to subtract it on both sides. That leaves us with X, and when we subtract 40.325 from 61.854, we get 21.529, still in square meters or meters squared. Riley uses a total of 7.5 square feet of fabric to make a banner in the shape of a triangle. He uses a piece of striped fabric in the shape of a right triangle with perpendicular sides that measure 1.5 feet and 3 feet. He uses a piece of dotted fabric in the shape of a right triangle with one side that measures 3 feet. What is the measure of the other side of the piece of dotted fabric that is perpendicular to the side that measures 3 feet? So we're finding that missing length here. We know that it has a total of 7.5. Let's start by figuring out this piece. So this piece has an area of 1.5 times 3 times a half. Well, 1.5 times 3 is 4.5, and half of that is 2.25. So if we subtract that from 7.5, that'll tell us the area of the dotted fabric. Because 7.5 is the total, and then 2.25 is this striped fabric. So I know that the area for the blue or the dotted fabric is also going to be found by using A equals B times H. I just found out that the area was 5.25. and I know that it has a height of 3. Half of 3 is 1.5. So I can use this equation 5.25 equals 1.5b and solve that to figure out this missing side length. I'm going to divide both sides by 1.5. That will leave me with b over here. And 5.25 divided by 1.5 is 3.5. So that missing side length is 3.5 feet. Toby, Sasha, and Lacey stand in a triangle. The area of the triangle they form is 40 square feet. Toby stands 10 feet from Sasha. Determine the height of the triangle. Draw and label the triangle to show where Lacey could be standing. So let's see, we've got Toby, Sasha, and somewhere up here we have Lacey. With an unknown height. We were told the area was 40 square feet. So I'm replacing A in the equation with the number 40. And here I see the base is 10, so I'm going to replace B with 10. And I need to solve it for H. Half of 10 is 5. So I have 5 times H. To solve this equation, I'm going to divide both sides by 5. This is H on the right, and 40 divided by 5 is 8. So this height must be 8 feet. She could also be standing 8 feet this direction. We could form our triangle in an upright manner or this direction. That's all for lesson 4. Make sure that you have it filled in your workbook with all of the work and steps shown for these problems.